far beyond the reach of coastal waters, where the ocean becomes an endless blue void, a predator moves with a shape so strange it feels almost unreal. Sleek, silent, and armed with a tail longer than its own body, the pelagic thresher shark is one of the most mysterious hunters ever discovered in the open sea. It does not hunt like other sharks. It does not rely on brute force alone. Instead, it turns its own body into a weapon, striking through schools of fish with a whip-like tail in a way that has stunned scientists and fueled ocean legends for generations. In today's Abyssal Chronicles documentary, we descend into the haunting world of Alopias pelagicus to uncover how it lives, how it hunts, and why this elegant phantom of the deep remains one of the least understood predators in the ocean. Before we dive deeper into the abyss, make sure to subscribe to Abyssal Chronicles, leave a like, and join us on this journey into the darkest mysteries of the ocean. Imagine a place where sunlight dies, where pressure stacks itself layer upon layer until it could crush steel, where the ocean stops feeling like water and starts feeling like another planet. In that world, something long and blue-gray moves just beyond sight. Not fast at first. Not loud. Just present. Then, in a flash, its body folds like a drawn bow, its tail arcs over its own head, and the darkness itself seems to crack. A school of fish scatters too late. For a second, the abyss has a whip. And that whip belongs to the pelagic thresher shark, Alopias pelagicus, one of the strangest hunters ever shaped by the sea. Scientists now know this shark really does use its tail to hunt, and decades of observations in the Indo-Pacific have shown that the species lives in offshore waters, ranges widely, and visits certain shallow seamounts with almost ritual precision. At first glance, the pelagic thresher does not look built for the deep. It looks built for mythology. Its upper tail lobe can be almost as long as the rest of its body, turning the animal into a living exclamation mark. The body is lean, streamlined, blue-gray above and pale below, with a metallic sheen that can make it look almost ghostly in clear water. Its teeth are surprisingly small for such a dramatic predator, smooth-edged and delicate-looking, which tells you something important right away. This is not a shark that depends on brute jaw power. It is a precision hunter, a specialist. The pelagic thresher is most often found in warm and temperate offshore waters of the Indian and Pacific Oceans, though records near coasts do occur, and confusion with related thresher species has made its true range harder to map with certainty. To understand why it looks so unnatural, you have to go back far beyond human memory. The thresher shark family, Alopias, appears in the fossil record roughly 55 million years ago, not long after the world that killed the non-avian dinosaurs had already passed into prehistory. Later fossil finds show that giant thresher relatives swam Miocene seas, proof that this strange body plan is not an experimental accident of recent oceans but part of a lineage that has endured massive planetary change. Continents shifted. Ocean gateways opened and closed. Climate warmed, cooled, and warmed again. Entire marine faunas rose and vanished. Yet the thresher design remained. That persistence suggests evolutionary success, not in domination, but in specialization. The family seems to have found a hunting strategy so efficient, so unusual, that it carried them across deep time while many other pelagic predators disappeared into stone. The prehistoric world that shaped the pelagic thresher was not a calm blue paradise. It was a restless machine. Early Cenozoic seas were crowded with fast fish, ancient whales, squid, and competing sharks, all living in a three-dimensional battlefield where speed, temperature, oxygen, and light decided who ate and who starved. In that world, the ancestor of the pelagic thresher did not need to bite harder than every rival. It needed to solve a different problem. How do you catch many small, agile fish that survive by moving together? Schooling prey are confusing on purpose. They blur into one body, one flickering surface, too many targets at once. The pelagic thresher's answer was extraordinary. Rather than chase a single fish with jaws alone, it evolved a weapon built into the back half of its body, a tail long enough to become a strike. That may be the key reason this lineage lasted. It stopped hunting the way most sharks hunt. And that tail is not just long. It is engineered. Researchers studying pelagic threshers found that their hunting strike is not a random lash but a coordinated sequence of body motions. The shark accelerates, changes pitch, lifts its rear body, winds up, and then drives the tail through the water with such speed that bubbles can appear near the apex of the strike. In observed hunts, the blow can stun multiple sardines at once. One successful filmed event showed a pelagic thresher debilitating and consuming 3 sardines. Another resulted in 2. The researchers concluded, in words that sound almost relieved, the evidence is now clear. Thresher sharks really do hunt with their tails. This matters because for generations the tail strike was treated as rumor, fisher's knowledge, or naturalist suspicion. Modern video turned legend into measured behavior. That single fact changes how you see the animal. The pelagic thresher is not a monster with a bizarre ornament. It is a living physics experiment. The tail is a whip, a net, and a shockwave generator all at once. In dense schools, that matters. Most large ocean predators pursue one prey item at a time. The pelagic thresher tries to break the rules. According to the hunting study, about 1/3 of observed overhead tail slaps resulted in prey being collected, and when the strike worked, the shark often got more than one fish. That means the hunt is a gamble with a jackpot. Spend energy, risk failure, but if you connect, you may take several prey in one motion. In the open ocean, where meals can be scattered and costly to find, that efficiency may be worth everything. Its world, meanwhile, is almost impossible for us to feel properly. The pelagic realm is not empty water. It is a vertical wilderness. Near the surface, there is brightness, temperature, and glittering baitfish. Below that, the light thins to cobalt, then indigo, then black. Pressure builds with depth. Temperatures can drop sharply across thermoclines, and oxygen can become scarce in deeper layers. The pelagic thresher lives in this shifting architecture, usually from the surface down to around 150 meters in many descriptions, but tagging studies have recorded individuals diving far deeper, including to 250 meters in the Visayan Sea and to at least 632 meters in the Red Sea. Those dives suggest a shark that does not simply cruise a fixed band of water, but negotiates an invisible landscape of heat, oxygen, prey, and physiological limits. What allows it to cross those gradients is one of the most elegant pieces of shark biology, a heat-conserving circulatory system called the rhetia mirabilia. In simple terms, the pelagic thresher can retain internally generated warmth better than many fish around it. Warm venous blood transfers heat to cooler arterial blood through closely packed vessels, helping conserve temperature and keeping muscles working efficiently in cooler water. This is not full mammalian warm-bloodedness, but it is a powerful evolutionary advantage. It means the shark can move between layers of the ocean without becoming sluggish too quickly. Some scientists studying dive behavior suggest the species may return toward shallower water to warm back up after deeper excursions, dancing at the edge of its own thermal limits. In a sea where a few degrees can change reaction speed, that may mean the difference between hunting and missing, surviving and fading. The dive records also reveal something more haunting. The pelagic thresher may spend much of its time negotiating trade-offs it cannot fully win. Researchers have suggested its oscillating dives could help with thermoregulation, respiration, or intercepting prey-related scent plumes, while also avoiding increasingly hypoxic waters below certain depths. In the Red Sea, one tagged individual avoided the cooler, more oxygen-poor depths where prey were likely concentrated during the day and instead overlapped more with small epipelagic fishes at night in warmer surface layers. In other words, the shark may sometimes know where the food is but be unable to stay there comfortably for long. That gives the species a tragic edge. It is not an invincible hunter ruling the deep without limits. It is a specialist navigating constraints written by temperature, oxygen, and anatomy. Then there are the places where mystery rises from the abyss into shallow water. Off the Philippines, at Monad Shoal, pelagic thresher sharks have been observed for decades visiting a coastal seamount where cleaner wrasse pick parasites from their bodies. That alone is extraordinary. An oceanic shark, usually imagined as remote and inaccessible, arriving at a predictable cleaning station like a patient entering a clinic at dawn. A 2011 study documented these interactions and suggested they may help explain why these mainly oceanic sharks regularly venture into shallow coastal waters, where they become more vulnerable to disturbance from people. More recent work continues to show the ecological importance of these cleaning stations. For divers, these moments feel almost sacred. For scientists, they are invaluable windows into a species otherwise hidden by distance and depth. One of the most astonishing observations ever made there came in 2013, when researchers photographed what appears to be the first recorded case of a thresher shark giving birth. A large female was seen moving in an agitated state across the cleaning station. Only later, when the photograph was examined, did the image reveal the head of a pup emerging from her cloaca. Think about what that means. In a place already known as a threshold between deep and shallow, between hidden life and brief visibility, a shark from the open ocean may have chosen, or been forced by circumstance, to cross into one of the most vulnerable moments of its life. Science rarely gives us scenes like that. It was not staged, not expected, and not fully understood. It was simply captured before the ocean could take the evidence back. There is another human layer to this story, and it does not come only from laboratories. In Indonesia's Alor region, a 2024 telemetry study notes that local shark fishers have long known pelagic threshers strike with their tails. Their traditional visual lures can end up foul-hooking the shark's caudal fin when the animal attempts to stun what it perceives as prey. That is a remarkable convergence of knowledge systems, local experience and formal science arriving at the same truth. For years, fishers knew the tail was not decoration. Researchers later quantified the mechanics. This is often how the ocean reveals itself, not through one heroic discovery, but through fragments of understanding held by different people for different reasons, suddenly locking together into a larger picture. The abyss is not silent because nothing is known. It is silent because knowledge there comes in flashes. Diet studies reinforce that picture of a hunter built for mobile pelagic prey. A 2023 trophic study from the southeastern Pacific found the pelagic thresher feeding across upper trophic levels, with diet items including multiple squid species and fishes. That fits the image emerging from behavioral work. This is a predator of schooling, fast-moving organisms in open water, not a scavenger drifting passively through emptiness. And yet its small teeth and specialized tail make it feel almost paradoxical. It is a shark, but in some ways it solves problems more like a cetacean or a billfish would, by manipulating prey groups, by exploiting timing, by turning motion itself into a weapon. When you imagine it moving through a silver cloud of sardines or squid in blue-black water, you begin to understand why it survived. It is not generalized. It is exquisitely tuned. Still, specialization can become a trap when the world changes too fast. The pelagic thresher matures relatively late, has low fecundity, and lives in the same pelagic zones worked intensively by longline and gillnet fisheries. That combination is dangerous. It means losses are not quickly replaced. A recent Australian report card, drawing on IUCN assessments and broader regional data, classifies the species as globally endangered and notes declines greater than 70% over a 55-year period across parts of its range. It is also listed on CITES Appendix 2 and CMS Appendix 2, recognition that international trade and migratory conservation matter for its future. The same adaptations that made the species successful in open water, wide movements, predictable use of productive zones, attraction to schooling prey, also bring it into contact with industrial fishing gear again and again. There is a cruel irony in how the pelagic thresher dies. A shark evolved to strike prey with its tail can become hooked by that same tail. A hunter adapted to the upper layers of offshore seas enters exactly the depth bands most heavily worked by fisheries targeting other animals. A species that may move across jurisdictions faster than laws can protect it becomes everyone's responsibility and no one's. Conservationists worry not only because the animal is beautiful or strange, but because its life history offers little margin for repeated loss. Even where management is stronger, as in some Australian fisheries, The species forms part of wider regional stocks affected by fishing pressure elsewhere. The ocean does not respect borders. A shark that crosses whole basins cannot survive on local protection alone. And yet the pelagic thresher keeps secrets. We still do not fully understand its migration routes, stock connectivity outside some Pacific units, or the complete logic behind its vertical movements. Tagging studies have filled some gaps but opened others. Why do some individuals dive more deeply or more often than others? How much do prey, oxygen, temperature, sex, reproductive state, and cleaning needs shape those patterns? Do certain seamounts function as biological hubs the way airports do for human travel? Are there nursery areas we have barely recognized? With oceanic species, absence of evidence is almost never evidence of absence. Much of their lives occurs where humans visit briefly, if at all. The pelagic thresher is visible just enough to fascinate us and hidden enough to remain half-mythical. That is why stories grow around animals like this. In the imagination, the pelagic thresher becomes a phantom of the blue, a blade-tailed specter, a forgotten relic from a primeval sea. Some of that is exaggeration, but not all of it. When a lineage reaches back tens of millions of years, when its anatomy seems almost designed by folklore, when it appears at dawn above a seamount to be cleaned by tiny wrasse and then vanishes into water dark enough to erase color, myth is not the opposite of truth. Myth is what truth feels like before enough data arrives. The responsible thing is to separate what we know from what we suspect. We know it hunts with its tail. We know it dives deep. We know it visits cleaning stations. We know it is in trouble. What we do not yet know may be just as important. So picture it one more time. A pelagic thresher rising from deeper water into a dim layer of morning blue. Its body is cool from depth, its muscles holding borrowed warmth, its eyes scanning a scattered flicker of prey. Maybe it has followed vertical migrations through the night. Maybe it has come from a cleaning station. Maybe it is pregnant. Maybe it is crossing invisible borders between countries that do not know it is there. It finds a school. The fish tighten. The shark turns, accelerates, folds the geometry of its body into a weapon, and strikes. A burst. A shimmer. A few stunned bodies tumbling in the blue. Then the hunter wheels back, efficient and ancient, gathering what the tail has made possible. In that instant, evolution, physics, hunger, and deep time all meet in one motion. And maybe that is the lasting power of this animal. The pelagic thresher shark reminds us that the ocean still contains solutions stranger than fiction. It reminds us that survival is not always about being biggest or most brutal. Sometimes it is about finding one impossible trick and refining it across millions of years until it becomes art. But it also reminds us how fragile even ancient designs can be in the modern age. A species can outlast climate shifts, tectonic change, and vanished seas, only to be undone in a historical instant by lines, hooks, markets, and appetite. The abyss did not make this shark weak. It made it extraordinary. Whether extraordinary is enough now depends not on the shark, but on us. So the next time you imagine the deep ocean, do not imagine emptiness. Imagine pressure like a cathedral of stone. Imagine darkness layered with cold fire from drifting bioluminescent life. Imagine schools of fish moving as one mind. Imagine a shark so specialized that its own tail became a weapon, so elusive that for years people argued over how it hunted, so ancient that its family has ridden out epochs, and so vulnerable that we may lose it while still learning how it lives. Somewhere below the reach of easy light, a pelagic thresher is still moving through that alien water, blue-gray and silent, carrying an old design into an uncertain future. And that may be the most unsettling mystery of all. Not that the deep can produce such creatures, but that it can hide them from us for so long, even as they disappear.